Hello friends, welcome to all of you in Electra classes. Myself Nikhil Bunkar, and today we are going to start our new topic in the series of current electricity chapter. And our today's topic is the relation between drift velocity and electric current. In previous lecture, we discussed about the term drift velocity and how electric current flow in the case of drift velocity, or how electric current flows when we connect a conductor with the help of a battery, or when we put any conductor in the presence of electric field. But now in today's lecture we are going to discuss about the relation between drift velocity and electric current. So as you can see in the diagram, a L length conductor is as shown, which is connected with the battery. Okay, here both the ends of the conductor is connected with the help of a battery of potential V. And in previous lecture we discussed that when we connect any battery with a conductor, in that case there is an electric current flows in the direction of electric field. So what is drift velocity? You all are familiar in previous lecture. So let us take a small brief regarding the previous lecture. So the drift velocity is the velocity attained by the electrons when they are attracted towards the positive terminal of the battery. Means the drifting of the electron by a particular or a certain velocity, or the average velocity by which the electrons are attracted towards the positive terminal of the battery, is known as drift velocity. Means the electrons are attracted towards the positive terminal of the battery when it is connected with the battery. So the drifting of the electron towards the positive potential by a certain average velocity, and that particular average velocity is known as drift velocity. So in the case of drift velocity, or when we connect the conductor with the help of a battery, and in that case there is an electric current flows through the conductor, as you can see in the diagram. So here the electric field is such that in the direction, as you can see in the diagram, in the direction of electric current and the electric field both are in the same, as we discussed in the previous lecture. So the drifting of the electrons, Vd is the drift velocity of the electron, and the drifting of the electrons, as you can see in the diagram, that is towards the positive terminal of the battery. So let us consider there is a L length of conductor and whose cross section area is A. Let V is the applied potential difference across the ends of the conductor. As you can see here in the diagram, here V is the potential difference, or a battery V potential difference is applied across both the ends of the conductor. Now, as we know that the magnitude of electric current is given by I equals to Q by T. Here I is the electric current, Q is the charge, and T is the time taken. This is the first equation regarding the or expression. And also we know from the quantization of charge, this quantization of charge was discussed in the electrostatics unit. So quantization of charge can be given by Q equals to NE. Here E is the charge of electron, and this is our second equation. Here N is the total number of electrons, Q is the total number of charge, N is the total number of electron, and E is the charge or the value of one electron. Okay, and that is, we all know, minus 1.6 multiplied 10 raised to minus of 19 coulomb. Okay, now if total number of electron per unit volume is small n, as you can see in the diagram, this is the L length of conductor, and let we consider the total number of electron present inside this whole conductor, inside this whole over n volume. Let consider the volume of the whole conductor, that is n. So inside whole n volume of the conductor, the total number of electron present inside the conductor is to be considered as small n. So as we see, the total number of electron per unit volume is denoted by small n. So this can be written as small n equals to capital N by V. As we say, total number of electron, and the total number of electron are represented by capital N per unit volume, and volume is, let's consider V volume is there. So the total number of electron per unit volume is written as small n equals to capital N divided by V, and here capital N is the total number of electrons and V is the volume. So total number of electron per unit volume is denoted by small n. So it can be written as capital N is equals to NV by cross multiplication. Now here V is the volume, and we all know the volume can be written as the area multiply length. Okay, there are three dimensions in volume, so volume can be written as area multiply length, and here as we consider the area is A and the length is L, so the volume can be written as A multiply A. Here A is the area and L is the length of the conductor. Now put the value of equation third to the equation second. As we can see, the value of equation third is capital N equals to small n AL, and the second equation is this one. So now we put the value of n, capital N, into the first equation, that is Q equals to capital N. In the place of capital N, we are going to write the value of capital N from equation third. So the next term will becomes capital Q equals to NALE. So these are fourth equation. Now time taken by electron to cross the L length of conductor with the average velocity Vd. So according to this term, the electrons are drifting towards the positive potential by a particular force F and by a particular velocity Vd, and that term is known as drift velocity. So the electrons take some time to cross the whole length of the conductor. Okay, electrons are started to drifting from here, from this end. Let us consider the electrons are started drifting from this terminal when they are when the conductor is connected with the help of a battery. In that case, let us consider the electrons are started to drifting from this terminal and they cross whole the length L. They cross whole the length L to cross out to reach the positive terminal of the battery. Okay, electrons are started from drifting from here, and they cross whole L length to reach at this terminal. Yes, so let the time taken by the electron to cross the whole length L of the conductor, and that time is T, let to be considered. So in that case, what we can write, the time taken by the electron to cross the L length of the conductor when they are drifting towards the positive terminal of the battery. So the time is given by, as we all know, the time equals to the basic formula, distance divided by velocity. Okay, so here what, the distance covered by the electron, is L, and that is the length of the conductor, and the velocity of the electron is the drift velocity. Okay, that is Vd, and T is the time taken by the electron to cross the L length of the conductor. So time is given by L divided by Vd. Okay, now put the value of equation 4 to the equation 5th. So as we can see here, from equation 4 the value of Q is given, okay, and equation 5, okay, that is time is given. Okay, so now we have to put the value of equation 4 and equation 5 in the equation first. So value of Q and T, now we are going to put the value of Q and T in equation first, and that is what, I equals to Q by T. So in the place of Q and in the place of T, we are going to put the value of equation 4th and 5th. So the next term will becomes NALE. In the place of Q, the value of equation is what, NALE. So and in the place of T, what we write, L divided by drift velocity. So the simplification terms will becomes I equals to NEAVD, and this is a relation between electric current and drift velocity. And here I is the electric current, N is the total number of electron per unit volume, E is the value of charge, and that is we all know minus 1.6 multiplied 10 raised to minus of 19 coulomb. A is the cross section area and meter square, and Vd is our drift velocity. So this is our final expression which shows the relation between electric current and drift velocity. As you can see here, I is the electric current, E is the charge of electron whose value is already we discussed, E is cross section area, and Vd is the drift velocity, and N is the number of electron per unit volume. Now we discuss some conclusion regarding this whole relation. As we discuss the relation between the electric current and drift velocity, so after that there are some conclusion we will observe, and that conclusion we are going to discuss about it. So as you can see in here, since the relation between the drift velocity and mobility is given by Vd equals to mu E. Okay, all we are familiar that the drift velocity is directly proportional to the electric field. Okay, the drifting of the electron towards the positive potential, it depends on the strength of the electric field. Okay, as we see here, as we connect the battery, in that case there is an electric field is generated. So the strength of the electric field will decide that how much force by how much force the electrons are attracted towards the positive potential. Means the drift velocity or the velocity of the electron is depends on the strength of the electric field. Means the strength of the electric field is greater, in that case the drifting of the electrons towards the positive potential is also greater. Means we can say the drifting of the electrons towards the positive potential is depends on the strength of the electric field. Okay, so the strength, the drift velocity of the electron is directly proportional to the strength of the electric field. So if we remove this proportionality sign, in that case there is a mu term is to be originated, and here mu is the mobility of electron. Mu is the mobility of electron, mobility. Okay, and mobility of electron is greater than the mobility of proton. Okay, the positive charge, we can see mobility of negatively charged particle is greater than the mobility of the positively charged particle, which we will discuss in the next lectures. But here the drift velocity is directly proportional to the electric field. So Vd equals to mu E, and here mu is the mobility. Okay, now put the above equation to the equation 6, and equation 6 is or what which equation? Equation 6 is this one, I equals to NeAVd. So now put the value of Vd from the equation, from this equation, so the next term will becomes I equals to NeA mu E, and these are another equation, and this equation shows the relation between electric current and mobility, electric current and electric field. So there are some conclusion, we will see. The first equation, I equals to NeAVd, and this is the relation between electric current and drift velocity. So according to this equation, we can say that the electric current is directly proportional to the drift velocity. Yes, the electric current is directly proportional to the drift velocity. Now, according to above equation 7, what we can write, the electric current is directly proportional to the applied electric field. Okay, because the equation is what? I equals to NeA mu E. So electric current is directly proportional to the electric field, and also the electric current is directly proportional to the drift velocity. So this is all about our today's lecture. I hope you enjoy this lecture. If you have any kind of doubt, in that case you can comment on our comment box. Okay, thank you.